Today's session is about Newton's forward and backward interpolation. So before understanding that, we have to understand what is forward difference operation. So let's take y is equal to f of x. So x value is a plus h, a plus 2h, a plus nh, etc. So here we see the increase in the value of x in forward direction. Forward direction is increasing. Okay, so corresponding y naught value will be y naught, corresponding y value is y naught, y1, y2, yn, etc. Here x is called as arguments, y is our entries, and h is difference interval. Now let's understand the forward difference operator. It is given by symbol delta. So here delta y naught is equal to the forward value minus current value. Okay, here the current value is y naught, you know? So forward value, the value which is ahead, minus current value. Forward difference operator, you have to think that the difference is between forward value and current value. That's it. Okay, that is the key point. So here delta y1 will be the forward value minus current value, that is y2 minus y1. Similarly for y, delta n is equal to delta n will be equal to y n plus 1 minus y n. Similarly for functions also. See, for example, delta f of a is equal to the forward value is a plus h. So function of forward value minus the current value. Okay. Similarly for delta f of a plus nh is equal to function of forward value minus function of current value. Okay. So this is first forward operators. Now second forward operator is given by delta square. That is what here this is multiplied by delta. That's it, nothing else. So here when we multiply this with delta, we get delta square y naught is equal to, when we multiply y1 with delta, we get delta y1 minus, when we multiply this with delta, we get delta y naught. Okay, so to generalize, we can write like this. Now similarly, kth forward difference operator is delta k. So here also, so you have to write delta k yn is equal to delta k minus 1 yn plus 1 minus delta k minus 1 yn. So here we are writing k minus 1, here k, because here we have delta and here we don't have delta value. Okay, so this value, that is value towards the right hand side, is always, they have one delta value always less than the delta value here. Okay, that is why we are writing here k and here k minus 1, k minus 1. Okay, now how to form the difference table? So here we have to enter x value here, a plus h, a plus 2h, etc. Then y value, y naught, y1, y2, y3, and so on. And delta is here the forward value minus current value, y1 minus y2, and so on. And similarly here delta square is again the forward value minus the current value. Okay, now let's understand backward difference operation. Here we have to take y is equal to f of x. Now here value of x is a minus h, a minus 2h, a minus nh, etc. Okay, so here we see the decrease in the value. Okay, that means it's going backward at equal interval. Okay, so here it is going backward. So corresponding y value is y naught. Here this is y1, y minus 1. Here y minus 2, y minus n. So here two things we have to keep it in mind. Here the value is decreasing at equal interval, and that is, it's going backward. Okay, now let's understand this. So backward operator symbol is this. Here we have to understand that current value minus backward value. Okay, this is the only key point you have to understand. Current value minus backward value. Current value minus backward value. Here again, this is for y minus 1, the current value minus backward value. Okay, so that is the way. This is first backward operator. For second operator also same thing. Current value minus backward. For kth again same. So now for forming the difference table, it will be like this. Enter x value, then enter the y values, and delta will be current value minus backward value. Okay. Now let's understand what is interpolation. Interpolation: if the value of x for which the value of y is to be estimated is in intermediate value given the set of x, then the method of determining y it is called as interpolation. Interpolation method can be Newton's forward and backward interpolation where the values are placed at equal intervals. Lagrange's method when it is placed at unequal intervals, and binomial when the terms are missing. Now, today's session we'll be discussing about Newton's forward and backward interpolation. Here the formula is given here. This is forward interpolation formula and this is backward interpolation formula. We'll understand this with an example. Here, example 1. Form a difference table and interpolate the value of f of x when x is equal to 4. Now, first we have to find out whether we have to do forward interpolation or backward interpolation. So here the value, we have to see this value. This value is 4. This value is closer to the first value. If the value to be interpolated is close to the first value, then we have to use Newton's forward interpolation formula. If the value to be interpolated is close to the last value or towards the end of the table, then we have to use Newton's backward interpolation formula. Okay, so in this case, x is equal to 4, which is close to the first value. Hence, here Newton's forward interpolation formula is used. Now h is the difference between 2. Here 5 minus 3 is 2. 7 minus 5 is 2. 9 minus 7 is 2. That is the difference between two values. Okay, interval or difference interval. Okay, interval of two values, whatever you want you can take it as. Now p is given calculated by x minus x naught by h. X is the value to be interpolated minus x naught is the first value of x and h is difference interval. Here it is 4 minus 3 by 2. So p is equal to 0.5. Now let's construct the difference table. Here x is 3579. Okay, 3579. Y value is 180, 150, 120, 90. Delta value is 150 minus 180 minus 30. 120 minus 150 is minus 30. 90 minus 120 is minus 30. Delta square is minus 30 minus 30. Minus 30 minus of minus 30, which is 0. Here minus 30 minus of minus 30 is 0. And here this is again 0 minus 0 is 0. Now let's put it in the formula. Newton's forward interpolation formula is y of x is equal to y naught plus p by factorial 1 delta y into delta y naught plus p into p of p into p minus 1 by factorial 2. Factorial 2 is 2 into 1. Okay, and delta square y naught plus here p into p minus 1, p minus 2 by factorial 3. Factorial 3 is 3 into 2 into 1 and delta cube y naught. Now let's substitute the value. Okay, y naught value is 180 plus p is 0.5. If factorial 1 is 1, delta y naught is minus 30 plus p into p minus 1, that is 0.5 into 0.5 minus 1 by factorial 2, that is 2 into 1, that is 2. And delta square y naught is 0. So we'll put it here 0 plus p into p minus 1 into p minus 2. So p is 0.5, so 0.5 minus 1, 0.5 minus 2 by factorial 3, which is 3 into 2 into 1 into delta cube y naught. Delta cube y naught is 0. So simplifying it, we get 165. The following table gives the value of tan x for 0.10, which is less than or equal to x, which is less than or equal to 0.30. Find tan 0.26. This is a table given. This is x value and y value. This is x0, x1, x2, x3 and xn. This is y1, y0, y1, y2, y3 and yn. Whenever the value to be interpolated, if it is close to the first number, then we have to carry out with Newton's forward interpolation. If it is close to the last value, then we have to do Newton's backward interpolation. Here, this 1.26 is close to the last value. So here we'll be using Newton's backward interpolation formula. Let's form difference table. So here value of x we have to write, then value of y, and delta is difference of these two value. Difference of these two value here writing here. Similarly, delta square is difference of these two values. Delta cube is difference of these two values. And delta 4 is this. So here we have to calculate till delta 4. Now when we see Newton's backward interpolation, we have to take these values. Let's substitute the value in formula. So y is equal to yn plus q by factorial 1 inverted delta. This is called as nabla yn plus q into q plus 1 by factorial 2 nabla square yn plus q into q plus 1 into q plus 2 by by factorial 3 into nabla cube yn, and so on. Then here we have to the q is equal to x minus xn by h. X is the value to be interpolated minus xn is last value. We are taking here xn because we are doing backward interpolation, and h is difference interval. The substituting value here 2.26 minus 0.3 divided by 0.5 is this. Now substituting the value, yn is this plus q is this, and delta value is delta yn is this. Okay, 0.54 plus now q is this one minus 0.8 into q plus 1. So this is 0.8 plus 1 by factorial 2, which is 2 into 1, and this value is 0.10014 plus now here q value is this, then q plus 1 is this, q plus 2 is this, divided by factorial 3, which is 3 into 2 into 1 into into nabla cube yn value, which is this. Okay, now plus now next this is q plus 1, q plus 2, q plus 3 divided by factorial 4. Factorial 4 is 4 into 3 into 2 into 1 into nabla to the power 4 yn, which is this value. On simplification, we get y is equal to 0.26602. So the value or the interpreted value to be interpreted is this. We get this. This is the answer. Okay. Now, let's see another example. Here, example 3. The area of circle A corresponding to the diameter is given here. So area is this and the diameter is same. Area corresponding to the diameter is given here. Find the area corresponding to D105. So if D is 105, what will be the corresponding area? That is what they have asked us to find. So we have to use Newton's interpolation formula, but they have not given us whether it is forward interpolation or backward interpolation. Now since D105, it is close to the last value. Okay, it is close to the last value, so we will be using Newton's backward interpolation formula. So first we will form the difference table. X value we are writing here, y value we are writing it here, delta is difference of these two, difference of these two, and difference of these two. And now delta square is difference of these two. Okay, then difference of these two is 38, difference of these two is 40. Now delta cube, difference of these two is this, and difference of these two is this. And delta 4, and difference of these two is 4. Here, since it is Newton's backward interpolation, here we are using, we'll be using only these last values. Okay, now let's substitute this in equation. Newton's backward interpolation formula. So this is Newton's backward interpolation formula. Okay, now here q value is 104 minus 100 by 5, that is xn, the value to be interpolated, minus the value x naught value, xn value, which is x1 is the last value, which is 100, divided by difference. Okay, interval difference, which is 5. So on simplifying it, we get 1. Now we'll substitute the value. Yn value is 7854 plus q is 1 and factorial 1 is 1, and nebula yn is 766, which we have calculated in the table, plus q plus 1. So 1 plus 1 by factorial 2. Factorial 2 is 2 into 1. And nebula square yn is 40. Plus here q plus 1, q plus 2 by factorial 3, and this nebula q value is here 2. Plus here q plus 1, q plus 2, q plus 3 by factorial 4, that is 4. Factorial 4 is 4 into 3 into 2 into 1, and this value is, which we calculated in the table. We can refer to the table and we get 4. Okay, on simplifying it, we get this. Y is equal to 8666. So area corresponding to the diameter 105 is this. This is the required answer. Example 4. From the following table, find the number of students who obtained less than 45 marks. Also estimate the number of students scoring marks more than 40 but less than 45. So here there are two parts. First, we have to find number of students who obtained less than 45 marks, and second, estimate the number of students who scored more than 40 but less than 45. Okay, so this is a table given here. Here we have to interpret 45, which falls in, which is close to this value, first value. So we have to find Newton forward interpolation form. We have to use Newton forward interpolation formula. Let's form the table first. So x. So this is given the continuous, 30 to 40, it's a continuous thing. So we'll write it as less than 40. Less than 40, number of students scored is 31. Less than 50, number of students scored is 42 plus 31. Okay. Similarly, less than 60, it will be all these three values together, which comes to 124. And less than 70, sum of all these four values, which comes to 159, and less than 80 is 90. That is sum of all these five values. Delta is 73 minus 31, which is 42, 124 minus 73, which is 51, 159 minus 124, which is 35, 190 minus 159, which is 31. Delta square is 51 minus 42, which is 9, 35 minus 51, which is 16, minus 16, 31 minus minus 35, which is minus 4. Now delta cube is 16 minus of 9, which is 25, minus 4 minus 16 is 12. Now delta 4 is 12 minus of minus 25, which is 37. Okay, so we got all the values. Now we have to substitute the value in the Newton forward interpolation formula. Here, since it is forward interpolation, we have to take these values. Okay, now this is the formula given here. So first part of the question says number of students who obtained less than 45. So here 45 is the value which has to be interpolated, which is x. Okay, so p is equal to 45 minus x naught. This is x minus x naught. X naught is given as 40 divided by h, the class interval, which is 10. Simplifying this is 0.5. Now we got all the values, we have to substitute in the formula. So y is equal to y naught is 31 plus p is 0.5 and delta is 42 plus 0.5 into 0.5 minus 1 by factorial 2. Factorial 2 is 2 into 1 and delta square is 9 plus here p into p minus 1 into p minus 2 divided by factorial 3, the value, and here delta cube is minus 25. Now we have got one more value, so this is p minus 1, p minus 2 and p minus 3 divided by factorial 4, which is 4 into 3 into 2 into 1 into delta to the power 4, which is 37. On simplifying this, we get 47.86, which is approximately 48. So for 45, that is number of students who scored a mark less than 45 is 48. Okay, now we'll go to the second part of the question. Number of students who scored marks more than 40 but less than 45. Okay, so we know the number of students who scored less than 45. From the part 1 we got it is 48, and number of students who scored less than 40, it is given as 31. It is given in the table, refer to the table. Okay, now the number of students who scored between 40 to 45 will be this minus this, which is 17. Okay, so 17 is the answer.